The idea behind our project is to give surgeons the capability to become even better and to carry out interventions that are currently impossible. They're very good at what they do. They have very high success rates, especially in vitreoretinal surgery. But there are certain interventions, future interventions, like delivering therapies deep inside the eye with anatomical structures that are as thin as the human hair, that are just impossible to do due to the nature of human dexterity. And so we are developing robotic systems that allow surgeons to do exactly that, go within the human eye and operate with the finest precision possible. The solution that we are offering is something called a Continuum robot. So a Continuum robot is a robot that can take a variety of shapes, kind of like an elephant trunk. So one part is immobile and the other part is moving. The robot we are making is 0.5 millimeter. It will go inside the eye, and then its tip will be as dexterous as the elephant trunk. So we are trying to mimic the wristed dexterity of the human, but within the confined space of the eye. And with that, we are able to allow surgeons to do interventions that they would not normally be able to do with a straight instrument. Patients, of course, are the ultimate benefactors of this technology. We are developing a surgical robotic instrument that will deliver therapeutics that will tackle and be relevant for a variety of degenerative vitreoretinal and retinal diseases. So the population that currently suffers from such diseases will know that there is a delivery mechanism so that the therapies that are developed for them will go exactly at the right place with the right quantity, because robotic technology allows surgeons to do that. If we don't follow through this sort of technology and embrace the concept of enhancing dexterity with surgical robotics, we will never be able to reach the next step in healthcare delivery. So our mission as a school is to engineer better health, and we can do this by the development of smart instrumentation that kind of merges and marries the cognition of humans, so the expertise of humans to understand how to act in certain conditions, with the superhuman dexterity that is offered by surgical robots. And if we don't do that, then we are going to miss on this opportunity, and healthcare will not take this leap forward. The hospital of the future will be an environment where artificial intelligence, data, smart instrumentation, new operating procedures all merge together so that everything works in an optimized and very patient-specific fashion. So we can imagine that the patient comes in and there is automatically a report downloading to the clinician screen that directs them how to carry out this specific procedure. It pulls out formal procedures that informs them about complications, and then all this information also links with the robot that provides the additional dexterity that maybe highlights critical areas of the surgery. But ultimately we will have a merge of artificial intelligence provide cognitive support to the surgeon and smart instrumentation providing dexterity support to the surgeon. So the operating room of the future will be this sort of new merge between technology from computer science and technology from robotics. I came into the world of surgical robotics by serendipity. So as a student, I liked medicine. I liked the ideas behind medicine, but I wasn't comfortable with the sight of blood or the human anatomy, so this was not the most appropriate route. But then I was also good at engineering and maths. I liked computer science and all that, so I decided to take the engineering trajectory. And then during my PhD, I embarked on a project that was biomedical engineering, and specifically around ophthalmology. And so this allowed me to combine the worlds of medicine and engineering by creating devices for patient benefit, so getting the best of both worlds. My favorite robot is a tiny robot I saw in the Jetsons cartoon. And the Jetsons were a cartoon that was, I think, around 1960s, somewhere there it appeared. And for those that haven't seen it, it's like Flintstones, a family, but it's set in space and it's set in the future. And this tiny robot is a capsule that the patient had swallowed. And that capsule was taking pictures, and it had some end effectors to also do surgery, and it's just fascinating to see how so long ago there was this cartoon that was marrying concepts from Feynman's There's Plenty of Room at the Bottom and mechanical surgery and surgeons that navigate the human body, and still it gives us like a roadmap or a dream of something that we are still trying to develop.